Okay, this is section 1.1, an introduction to the vocabulary of our new year. The section is on angles and standard position and what that means. Historically, we have thought about an angle as being something very static. We've thought about it as being two rays, and in between those two rays, the angle is formed. Right? So they're rays. They have a common vertex, and between them is the angle. We're going to shift our focus now to thinking about an angle as being a rotation, so more like the two hands of a clock spinning around in circles. And we want to make it so that whenever we draw an angle of a certain measure, 50 degrees, 100 degrees, whatever, all of our angles look the same. So we're going to standardize our angles. We're going to put them into standard position. To put our angles in standard position, we need to know a couple of things. One, we're going to start drawing our angles on the coordinate plane. And just reminders, in the coordinate plane, this is quadrant 1, this is quadrant 2, this is quadrant 3 over here, and then lastly is quadrant 4. And what we're going to do is we're going to put our angle onto the coordinate plane. So we're going to have what we call our initial side, is going to be the ray that stays on the positive x-axis. Okay, so that's our initial side. It doesn't move. The side that does move, we call our terminal side. Terminal as in terminating, it ends, it moves, then it stops. So this is the ray that rotates through space. And because we're rotating, we can go around many times. So we can get angles that are 1,000 degrees. We can get angles that are 1,500 degrees just by spinning and spinning and spinning. And we also get angles that are negative by spinning in a different direction. We'll come back to that in a second. So in this diagram, I'm just going to say that, so let's say this right here is our initial side, and I'll give you a different color. This over here would be our terminal side. And then in between those, there is an angle that is formed. And we show the motion of the rotation by putting what I'll call a little spinner. I actually don't know its formal name. So I'm going to start with my pen on the positive x-axis. I'm going to show that this angle is going counterclockwise and just to there. Okay, so I need a rotation arrow, which I will call the spinner in class. To show the direction and distance traveled by the terminal side. Okay. Angles that rotate upwards are positive angles. So they go counterclockwise. I always remember it as they go up from the x-axis, because up is positive to me, right? You're thinking about the y-axis, above the x-axis is positive. And then negative angles rotate down. This is our basic vocabulary on angles: initial side, terminal side, positive angle, negative angle. There is one additional thing that we need to discuss, and we'll discuss that in the next video, and it's something called the reference angle. We need to put our reference angle in our diagram so that we know where the terminal side falls, since we don't expect our viewer to pull out a protractor every time they want to know where the angle is. So that will be the last thing needed on the picture, and we will do that in the next video.